You know how your phone recognizes your face to unlock? Or how Instagram just magically knows who to tag in your photos? Well, that's not magic. It's an incredible field of AI called computer vision. And today, we're going to pull back the curtain and see exactly how machines are learning to interpret the visual world, almost the same way you and I do. So, let's just start with a real-world test. Take a look at this scene. For us, it's pretty simple, right? It's a busy street. But for a self-driving car, this is just a chaotic flood of data. It has to identify every single pedestrian, track every other car, read the traffic signals, and stay in its lane, and do it all at the same time, in real time. Making sense of this chaos, that's the fundamental problem that computer vision was built to solve. You know, to really get how machines see, it actually helps to think about how we see. Our eyes have retinas that capture light, optic nerves that shoot those signals to the brain, and our visual cortex makes sense of it all. Well, computer vision is basically designed to mimic that exact process. A camera acts like the retina, the raw visual input becomes the data, and then these super complex algorithms, they act like our brain's visual cortex, doing all the heavy lifting of interpretation.
So here's our game plan for today. First up, we're going to break down the basic building blocks of digital sight. Then, we'll follow an image on its 5-stage journey, all the way from raw data to a recognized object. After that, we'll look at how this tech is already a huge part of your life, and we'll wrap up by looking at the really critical challenges and, yeah, the blind spots of AI vision.
All right, let's dive into the fundamentals. When you look at a picture, your brain just effortlessly processes all the shapes and colors. But what does a computer actually see? Well, it's not a picture. It sees a world of pure numbers. And it all starts with one tiny fundamental building block. And that tiny little element is the pixel. Honestly, the best way to think about it is like a giant mosaic, made of thousands or even millions of tiny single-colored tiles. Each one of those tiles is a pixel. So a computer doesn't see a face or a car, it just sees this massive grid of pixels, and each one has a number that represents its color. More pixels? That just means higher resolution and a more detailed mosaic. Simple as that. Okay, so how did numbers become colors? Well, for a simple black and white image, it's just a scale. Each pixel gets a value from 0, which is pure black, all the way up to 255, which is pure white. Pretty straightforward. But for color, things get a little more clever. The system uses what's called the RGB model. So instead of one value, each pixel gets 3. One for red, one for green, and one for blue. And this is where the magic really happens, because each of those 3 color channels, red, green, and blue, has 256 possible values. The total number of combinations is just staggering. We're talking over 16 million possible colors for every single pixel in an image. That's the secret code behind the rich, vibrant digital world we see every single day. Okay, so we've established that a computer sees an image as just a giant grid of numbers. But how does it get from that raw data to actually understanding what's in the picture? This is where the core process of computer vision comes into play. You can think of it like a 5-stage journey that every single image has to go through. This whole journey breaks down into 5 key stages. It all starts with acquisition. That's just capturing the image. Then it moves to pre-processing, which is all about cleaning the image up for analysis. Next is feature extraction, where the system starts to find basic patterns. After that, we've got detection, which is where it identifies specific objects. And finally, high-level processing puts it all together to understand the entire scene. So the journey begins with image acquisition, and it's exactly what it sounds like, just capturing the image with a camera or a scanner. But we all know from taking photos that not all pictures are created equal, right? The camera's resolution, the lighting, the angle you shoot from, all of it dramatically affects the quality of that raw data. And as they say in programming, garbage in, garbage out. You know, an image rarely comes in perfectly clean, which brings us to step 2, pre-processing. This is the crucial cleanup stage. Think of it like a photo editor, but for an AI. It uses noise reduction to get rid of any blurriness, normalization to standardize all the colors, and resizing to make sure every image is a consistent size. It's all about getting the data perfectly prepped for the real analysis. And now for the really cool part, feature extraction. This is where the machine has its first kind of aha moment. It starts seeing meaningful patterns instead of just a sea of pixels. Specialized algorithms scan the image like detectives looking for clues. They're finding edges where colors change, identifying corners where those edges meet, analyzing textures, all of it. These are the fundamental clues that are eventually going to build a picture of an object. So after the system has identified all those basic features like edges and corners, it's finally ready for the main event, actually finding and identifying whole objects. This is where all those previous steps really pay off, and the machine starts to truly understand what's in an image. The first big task here is object detection. See, it's not enough to know there's a cat somewhere in the picture. The system needs to know exactly where that cat is. So, powerful algorithms, some with cool names like YOLO, which actually stands for You Only Look Once, they scan the image, draw a little box called a bounding box around every object they find, and then slap a label on it: car, person, traffic light. But we can get even more precise than just a simple box. And that's where segmentation comes in, which works on a pixel-by-pixel level. Now, semantic segmentation is the first step. It basically colors in all the pixels that belong to a certain category, like car. But instant segmentation, that's the genius move. It doesn't just see cars, it sees car number 1, car number 2, and car number 3 as totally separate things. And this is absolutely vital for tracking individual objects when they're moving. Now, I know this might all sound a little abstract, but the reality is computer vision is already deeply, deeply integrated into our daily lives. You probably interact with it dozens of times a day without even realizing it. Let's just look at a few examples that might surprise you. I mean, think about it. Facial recognition unlocking your phone, that's computer vision. Social media suggesting who to tag in a photo, yep, computer vision. In healthcare, it's literally helping doctors analyze medical scans to find tumors. We've already talked about self-driving cars. Even scanning a document with your phone, that uses OCR, which is a type of computer vision. And of course, it's the engine behind modern surveillance systems. It is everywhere. But for as powerful as this technology is, it is not perfect. Not by a long shot. It faces some really significant technical challenges, and maybe more importantly, it raises some profound ethical questions that we really need to start talking about as a society. On the technical side, AI still struggles. It might be able to identify a fire hydrant, but it has no idea why a dog might be interested in it. Bad lighting or objects that are partially hidden can still totally confuse even the best systems. But the societal challenges, they're way bigger. Mass surveillance using facial recognition raises huge privacy questions. And of course, the rise of deepfakes, those perfectly realistic but totally fake videos, threatens the very idea of visual proof. And this really gets to the heart of the ethical dilemma. When machines can watch and identify us absolutely everywhere, we're faced with a pretty stark reality. The unchecked power of observation is the greatest threat to personal privacy. It forces us to confront a really tough question. Where is the line between security and our own freedom? Which brings us to our final and maybe the most important question of all. As this technology makes it easier and easier to create completely realistic but totally fake images and videos, we're stepping into a brand new era. So I'll just leave you with this to think about. What happens when we can no longer trust what we see? It's a challenge that goes far beyond technology, and it's one we're all going to have to confront.